Hi there, welcome back to the channel. Welcome to a new project. This one, as you can see, is on the breadboard. It's sitting right next to a world receiver. This is a Grundig Satellite 2100, and I'm sitting with a breadboard and a coil of wire stuck on here with blue tack. I've got an Arduino Nano, a rotary encoder, a display, a pot, and a few other little bits and bobs over there. And the idea is to take this project and put it on a little board which has been supplied by PCBWay. They sponsored the boards and the project. Thank you very much, PCBWay, for your support. So what exactly is it? Well, if I switch it on, you might get a better idea. We've got a display showing 460.9 and it's going up. I can adjust it, adjust the frequency. And what this is the Arduino is providing a signal to this AD9833. This board synthesizes or creates a sine wave at the frequency that you send it. And in this case, I'm sending it at, at this stage, 459.460 kilohertz. This happens to be the IF frequency of this particular radio. But I've made it flexible so that I can adjust it across quite a broad band. The idea is that I'll be able to use this for receivers with IFs at 455. There's been some at 457 point something. 460 is a very common one for the German sets, and some even as high as 472 if I remember correctly. And what this is doing is creating a signal which is being sent to this coil over here, which is acting as a tuned antenna, and that signal is being pumped into the IF stage of the receiver wirelessly, in other words, inductively, so that I can decode SSB signals, amateur band. So what we effectively have here is a wireless BFO, Beat Frequency Oscillator. Now, I built one before, and I did a project on that, and I still use it quite often. And it was this guy over here, where I had high-low signals. I had the level. I have a tuning adjustment here, and the signal would go out here, and it would connect to, well, some part of the IF chain of the signal. Sometimes you can just connect it to the antenna. It still works. This was fed with an external supply or with a battery that's internal. Now the problem I have here is that to adjust the IF, I have to literally go in there and adjust a core. I've got to put this on a scope, see what frequency I'm getting, and adjust it to, say, 460. If it's a 455 radio, I have to adjust it to 455. And that was just a bit of a bother. But as I said, this thing works very, very well. And I'll put a link to this project in the description below. I wanted to make it a lot more user-friendly, and because I've become quite enamored with the Arduino Nanos and the ease of programming, I decided to do this. And once again, I've got to tell you, I didn't program that. ChatGPT did. Yeah, I just kept telling it what to do. I incremented the various steps that I wanted it to do. And what I'll be doing at the end of this, provided it works well, is I'll be sharing these boards on PCBWay's share section on their website. I'll provide the Gerbers, the schematic, and also the code for this particular Arduino. And again, everything here was very, very cheap. I think the most expensive one was the AD9833, but we're talking a few bucks. And then all it's got is a transistor, sort of a buffer section, and a tuning stage for the antenna. All these components are very, very cheap. Let me show you what I did just earlier today on the 40 meter amateur band, and you can decide for yourself whether this thing's got a hope of working or not.
¿Recuerdas un día que empezaron a cambiar de banda y de frecuencia y nos perseguían?
Nos captaba en el aire. Era impresionante, claro, con esas operaciones que tenía.
No, pero bien.
La verdad que no hay queja, ¿no?
En el S5, porque yo cuando hablamos
Sí, estuve en Pontevedra, estuve una semana. ¿Qué me está hecho? ¿5? Pero ya estuve ahí hablando con Alfredo y tal, pero me conocía como...
Os 80 não basta. Agora, nos 40 é um espetáculo, essa pena, muito bom. E eu pensei em tirar
a parte dos 80, ok, mas põe a tempo.
Se não, talvez se ele vai tirar, vai estragar tudo.
No lo podría nadie.
Venga, cuestión hermano, 100 vatios por aquí, una antena FED, 5 metros de altura, 20 metros de hilo. Y el equipo es el Icon, el IC7300, el que he tenido estos últimos años por aquí, ¿no?
con el micrófono Sierra May 30 también de Icon.
¿Con qué equipo estás tú, mano? Adelante.
Hey, that works pretty well. It actually works very, very well. The adjustments that you make on here are just to accommodate for slight mistunings on the dial itself. If you had extra fine tuning on your tuner, you could leave this at a fixed amount, like about 1.2, 1.5 kilohertz above the IF or below the IF, depending on whether you're going for upper sideband or lower sideband. And then you can just tune it with the tuner till you get rid of the Donald Duck voice and you can hear the audio clearly. But because that's quite difficult with these tuners, I have a slight adjustment. I will be showing you exactly how this was designed, and I'll also just go through the logic behind this code. But what I want to do is get it onto this board, because I've actually gone one step further and I'm designing a little enclosure for it. I'm not quite sure how I'm going to put the loop on. It's probably going to be something that sort of extends from here, or maybe it'll be something that'll connect in here. This is still a work in progress, but this part I can do, and I want to do it just to make sure that I've got the boards working well, that I haven't made any stupid mistakes on here. It's happened before. So let me populate this, and then we'll get back to demonstrating, describing, and so on and so forth. Well, looks a bit different, right? I've soldered it all up, and no mistakes on the board that I can see. There are a few choices of placement here that I'll explain in a moment. Actually, I'll show you. I want to put it in a box like this one, which will be 3D printed, and I'll be providing the 3D print files. But basically what was on the board went onto here. No new components, nothing was wasted. It was all repurposed. It's the way I like to do things. So let's have a closer look. The Arduino Nano fits on there. The only pins that I actually solder are the ones that I use. So you'll see some of these are not soldered. That was on purpose. Just makes it a lot easier. It makes it easier to remove it if I have to as well. The AD9833 fits perfectly on there as well. The components on here, the only component that I did change was this transistor. I had that metal case one, and I replaced it with one of these normal ones, TO92s. The capacitors there, the diode. I'm using the 9-volt input over here. So I'm using VIN on the Nano. For that, I'll be using this battery. This one's rechargeable as well. I'm trying to make this as practical as possible at this stage. I could change it later, but that's the way it goes. And then I've got the encoder and the display coming out here at the bottom. Again, this was on purpose so that I can fit it into that enclosure. I've got the pot over here. It's one of those 90-degree pots, and I've got a switch here for the power. These fit into that hole in the bottom. But what I'm going to do now is just power it up. We'll see that that works. There are two components here that I need to show you. It's these two capacitors here that allow you to tune the antenna, the loop, okay? And it's two capacitors because you've got to put some in parallel. At the moment, I've only got one, so I don't really know at what frequency this thing is resonating. I know it won't be correct. I want it to resonate at, say, 457 or so, right? Between 455 and 460, because most of the radios are either 455 or 460. But let's switch this on and see if we've still got full function. Yeah, we do. And you'll notice something else. I've got this thing going up all the way to, what am I going to? I'm not even sure. Let me just click this in, step 1 kilohertz, and it goes up very high. And the reason I've got that going up very high is because I don't really know where this is going to resonate. It's going up to 570 kilohertz, and it's going all the way down to, again, I set the limits in the software, in the sketch, and I can't remember what I set them for. But it's going down quite a lot below 455, probably around 400, I guess. Yeah, 400. So I've set this purposely wide, and the reason is when I test this thing, and I'm going to test this to see if it's resonating by putting a scope across the coil, it sort of detunes it slightly, but not much. But when I do that, I'll be able to adjust the frequency and see where it's tuning. And then by adding or removing capacitance from here, I can bring it down to the 457 or so. And once I've got that done, then I can restrict the range that I'm getting on here. Because at the moment, 400 to 500, and what is it, 570 is way too much. I don't need that. So I'll be able to restrict it to, say, 450 to 470, for example, okay? And I can do that just by changing two variables or two numbers in the Arduino sketch. But before I do that, let me show you what the schematic looks like and very quickly describe what the sketch does. And then I want to come back to here and I want to show you the result of this on the scope and how we can tune it. We've got our Arduino Nano over here. We've got the AD9833 module over here. There's the encoder, there's the OLED. And the way this is powered is 9-volt battery connects there, it goes to that switch. And then I've got a little 47 microfarad capacitor there just to clean up any noise that may exist. This becomes my 9-volt line. And then we go to here, there's the 9-volt line. There's a 1N4, 148 die there just to prevent reverse polarity problems. I don't want to blow up or burn out my Arduino. 100 nanofarad decoupling cap over here, that goes to the VN pin. There's our ground. And then that provides a 5-volt line, which is what the remainder of the circuit uses. Now, I've basically followed the instructions where it tells you which IO pins to connect these two, the switch, the data and the clock, and then there's ground and the plus. Obviously the plus is 5 volts and ground. The OLED is about the same. Ground VCC, which is the 5 volts again, and then the SCL and SDA over there, A4, A5. This is relating to how this is programmed on the Arduino sketch. Same can be said for the AD9833. The way it's connected is the way the Arduino expects to see it according to the programming on the sketch. Now, what happens here is that whatever you program on here, whatever you switch in or dial up, it increments, and it increments in three different ranges. One, it can increment in 10 hertz, increment or decrease or decrease in 10 hertz steps, 100 hertz or 1 kilohertz, and you can flip between them by pushing the switch. That encoder's got a push button in the middle. You push it in, it changes the speed at which you can dial in the frequencies. The OLED just gives you the frequency, and what happens is whatever you've programmed in here, it comes out at this point here, out. And I'm using the same ground. I don't see that it's necessary, but I do have a solder tag on there that I can short if I need to, but I haven't needed to. And then we get to the buffer stage over here. I've actually just changed this. This is a 100K pot. What it does is it gives me sort of a level control. It comes out here at full level at about, I think it's about 0.6 volts. Peak, is it 0.6 volts? I think it's about 0.6 volts. But I can reduce it or increase it. I then feed this transistor, which is set up just as a emitter follower. I bias it halfway to the 9 volts. Oh, actually, I did use 9 volts here instead of 5. So I'll bias this to the 9 volts, and then this resistor is the emitter resistor, and over here you'll get the same signal that you have here, slightly attenuated. This capacitor really feeds the signal to the loop circuit. This resistor, it's acting as a low-pass filter. So I believe it'll help with any high-frequency harmonics. It'll cut off some of those. But the secret is here, because you've got the loop here, which is an inductance. And I can't even remember what the inductance was. I think it was about 100 microhenries. Yeah, I've just checked. It's about 100 microhenries. I think it was 30 turns of wire on that coil. But I'm going into more detail this in the actual build of the enclosure. And that tells us we need 1 point something nanofarads over here. So what I've got is I've got 1 nanofarad cap, and I had 100 picofarad cap, but I'm not sure that this is going to work now. At the moment, I've got the 1 nanofarad fitted. So I need to experiment to see what else I need to add on here to get this thing to resonate properly. But that's basically it. That's the entire circuit. It's fairly straightforward. On the 5-volt line over here, as it comes out, I put another decoupling capacitor of 100 nanofarads, and that is it. Let me show you the sketch. As I mentioned earlier, this sketch was actually written not by me, but by ChatGPT. I told it what modules I was using, I told it what I wanted, and then it wrote the code for me, and then I would copy and paste it into this IDE and test it, see the results, tell it what I was getting, tell it what I didn't like, what I did like, and it just went like that. Little steps till I got to what I wanted. And basically what we've got is It generates a sine wave using the AD9833. The range, I had it and will leave it at 450 to 470 for BFO use, and frequency adjusted via the rotary encoder, step size set by the push button, 10 Hz, 100 Hz, 1 kHz. Frequency is saved to EEPROM. I'm not sure that I'm keeping that, but if it stays on a particular frequency for longer than, I can't remember how many seconds, it'll save it. And on startup, the last frequency used is loaded. The OLED display displays the frequency with 2 decimal places. So we can actually go quite accurately down to, well, 2 decimal places, right? This is where you tell the system which pins you want to connect. For example, the generator to, the rotary encoder, frequency range for the BFO. The default startup frequency is 455. And here I've got the 400 to 570. I can simply change that to 450 and 470, re-upload, and I've got the range that I want. I want it wide for now because I want to be able to see where this thing resonates and what I need to do capacitor-wise to get it to resonate within that the smaller range that I want. Is there anything else? To change the rotary encoder steps from 10 Hz to 100 Hz to 1 kHz, you push the central button on the encoder, and that's really it. I don't think there's much else that. Obviously, I'll be sharing this on my Google Drive and it'll be shown below once this project's completed. But for those of you who want to get really nerdy on it, go ahead. And all I want to do now is I want to get this thing working, show it on the scope, show you the scope, see where it's resonating, and see what capacitances I need to add to get it down to 457 or so. I'll start by connecting the scope to here. Now, as I said, this does detune it slightly, but not much. I've got the scope on times 10, so it really doesn't affect it very much. And we should be able to see something on the scope when we switch it on. Let's power it on. Very little. There's something there, but very, very little. And because I've got a lower capacitor than I believe I'm going to need, I think I need to go up, and I'm going to go up in 1 kHz steps and just keep an eye on the scope. See where it jumps up. Oh, it's coming closer somewhere. Okay, let me change the leveling there. It's at 528. Whoa. Drop that again. There we go. It's peaking at 543. Well, that is far too high. So now what I need to do is I need to start putting in some capacitors on here, on there. And for example, where is that? I did have a 100 picofarad capacitor here somewhere, but it's gone walkabout. Probably on the floor somewhere. Not unusual. Yeah, that's another nanofarad. So let me go down. If it's really too much, and it is, it's going to get to 400 and it won't peak. So another nanofarad is too much. Let's see what else we can put in here. Here's a 500 picofarads. So we expect this to go up. Huh. That is close. 450. That's pretty close. So we need a 470. Okay. That should be easy to find. Here's a 470. Okay, let's see where we resonate at now. $461. That is pretty close. That capacitor is not a very good one, which is why we're getting quite a drop there. Let's see. I believe this is a 470 as well. Okay, let's try that. Damn, that's good. Ha! You see, that's also 470. It's a better quality cap. So it's peaking slightly higher. But we've also got, I don't remember what this is set to. I can adjust the amplitude. Ah, there we go. Let me bring the scope down. I had this pretty low. In fact, I had it very low. That is 2 volts peak to peak. There's full amplitude. And we bring it down. Okay. So where are we peaking exactly? There. 456. Now let's say that my radio's got an IF of 455. And I'll be going a couple of kilohertz above, a couple of kilohertz below. We've still got a very good signal there. And in this case, if I'm using a radio that's 460, see that? It's still a very good signal. And it's perfectly usable. And again, I'll obviously click this in to get, let's say, 100 hertz steps. 460, if it's, I need 461 or so, like I had it on the demo that I gave at the beginning of the video. That is a very good signal over there. And of course, my screen recording just cut out when I was talking about this. On this radio, which is 460 kilohertz IF, depending on whether I'm decoding on the, or trying to get a signal that's being sent on upper sideband or lower sideband, I'll go to either 461. I think it was picking up at 462 at one point, or 458 point something there. So that's a very good signal. And then if it's on the 455, it'll be 456 to about 454, 453. So these things are working very well. I expected more trouble setting this up. I really did. I thought this, finding the ideal capacitor for this was going to be a lot more difficult. But I'm going to leave this one here for now. And I'm leaving it in, just tacked in, because when I do the final assembly of this thing onto the enclosure, which I'm still designing, I'm not sure how I'm going to connect this. And if I decide to do it by a cable, the inductance changes, and so I'll have to change those again. The point is, this thing is working beautifully, and I've got this exactly the way I wanted. I will be changing the range so that we can go from 450 to 470. That's easy enough to do. I'll show you how I do that as well. I think you've probably realized that this will have a follow-up video where I put this into the enclosure and do the final testing and figure out how I'm going to connect the loop to the box. I actually wanted this thing to be completely self-contained, but I'm just not sure that I'm going to be able to do that. I may have to have like a plug-in loop. We'll see. Anyway, for now, this is it. The boards came, they worked. There were no mistakes on the PCBs. PCBWay did a great job again. And I want to thank them once again for their support. I will be providing all the information on this after I've completed the enclosure and putting this thing into the project box and doing the final testings. I don't want to risk finding something wrong and then misleading some of you guys. So after the next video, I'll be doing all that and providing the sketch, providing the schematics, links to where you can just order these boards if you like, and so on and so forth. So I do hope you've enjoyed that. And if you have, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon and PayPal. Links are in the description below. So once again, thanks for watching. Bye for now. And most of all, stay sane.